Hi friends, you're welcome to today's lesson. Today we're going to be solving some of the take-homes we are given to test ourselves on what we discussed in our previous lesson on calculation on isotopes. In our previous lesson, we did quite a very good job on calculation on isotopes, and we're given a couple of questions to test how much we learned from that very given lesson. So this was the very first question we were given. Boron exists as an isotope mixture containing 80% of boron 9, 15% of boron 10, and 5% of boron 11. Calculate the relative atomic mass of boron. We are asked to calculate the relative atomic mass or the average relative atomic mass unit of boron. Now, don't forget the formula. There's a formula given to us, to use each time we are asked to get the relative atomic mass unit of any given element, provided we are given the percentage or the isotopic abundance of the various isotope samples of that very given element. And don't forget, what's the formula? The formula is simply the summation of the partial atomic mass unit of each isotope given to us. Now, how do we get the partial atomic mass unit? Don't forget the formula also. To get the partial atomic mass unit, it is simply the isotope abundance over 100 times the given atomic mass of each isotope. That's what you're going to do. So it's very simple. So what I'm going to do first, the first isotope given to us is boron 9, the second is boron 10, and the last is boron 11. So we're going to be solving each of them. Going to be getting 80% of this, 15% of this, and 5% of this. So that's going to be 80 over 100 times the first atomic mass unit of the first isotope. This is over 1. Then summation, we're going to be adding them all up. So that's 15 over 100 times the next isotope, 10 over 1. Then the last 5 over 100 times 11 over 1. So we're going to be punching in these figures into our calculator to see what we're going to get. So by the time we get each of the, we're going to get a partial atomic mass unit for each of the isotopes. So the first we have here is 80 over 100 times 9 over 1. So let's punch that in. 80 times 9 divided by 100. So we have 7.2. So the partial atomic mass unit for the first isotope is 7.2. So the next 15 over 100 times 10 over 1, we can easily do this. 10 and 1, 10 and 10. That's 1.5. And then the very last one, 5 over 100 times 11 over 1. When you times this, 5 times 11 is 55. 55 divided by 100 will give us, you know what that's going to give to us? That will give us 0.55. 0.55. So when we do the mathematics, when we add them up, 7.2, 1.5,